Welcome to this crash course on Python. So I think I gave you the link to download this. Make sure that you download the whole of this material. After you download, right now I'll be using crash course on Python. So you upload it on Colab, and in Colab, this is what you will see when you upload it. So let's go through it. Okay, so in Python we have in other programming languages we have indentation that uses curly braces. For an example will be for C, you use curly braces for code indentation, separating different parts of a code. But in Python, we have what we call white formatting. As you can see in this example, for I in these lists, so we are printing the values out. Then we are having another for loop that prints other values. Then we are printing the inner values. Then we are printing the value I plus j, and we are printing I. So the important thing to note is that we are having space, white space here, and you're having space here to differentiate between the outer loop and the inner loop. So let's run this and see how it works. To run, you use Control Enter. Oh, it seems to work. The important thing to take out of this is that we're having two loops, for loop, and we are having one outside and another one inside of another. So let's move on. Then in Python we have modules. You can import modules in Colab. You can use this kind of cryptic looking like to save a file in Colab. Then in that file we're having just a function that is taking an argument. It's having a parameter name, and it will take an argument of a name and print it out. So let's run this. It seems now we are having our file, my example of module Python. Then next we import the file. And as you can see, I used input, so you can enter my name. And it prints out my name after calling the function. And first this is my module, then this is my function from the original module, as you can see. Now we are moving on. Next, we have in what we call mathlib. This is used to visualize in Python. As you can see, importing these modules. This is a module, then I'm importing another one, random. Then I'm having a list. In Python. We'll look into this more, not just in next minutes. I'm having two lists, list 1 and list 2, with the value from range 10, that will be 0 to 9 values. So then I'm using what we call shuffle method in random to shuffle numbers in these lists, list 2. Then I'm printing a scatter plot with lists 1 as X, list 1 as a x and list 2 as a y. Then plotting y using plot y label. I think that's just a label. Yeah, I'm labeling y. Okay, so I think let's run this. That works. So we've talked more about functions. Let's see functions in close. So in Python, we define a function by the keyword def, and as you can see, I want to have a function of an area of a circle, and I use import to import that math module to give me pi. So having using def of the keyword area of a circle, it taking in radius. That's a radius. The name is a parameter, as you can see. Then the argument is 5 in this example. So the area will be pi r squared, as you can see. From math, I'm getting pi. Then I'm having my radius squared. Okay, so when I call it, when I call the function with an argument 5, it gives me the area of a circle with the radius 5. That's work. So in Python, we have what we call first class functions. I think you can assign a function to a variable. In this example, we're having a function here with a parameter f, and it's just taking this argument 10, returning an argument of 10. So as you've seen above, area is equals to area of a circle, our function here. And now we are applying area. We are applying this area to a new function. So when you apply this, it's equivalent to applying 10 to our argument to our area of our circle. So that's really a radius of 10 will give us that. So we are moving on. In Python, we have what we call lambda functions. These are also known as anonymous functions. So their syntax, lambda. You have lambda. Then you have arguments and expression. An example here is we are assigning it to a variable. So lambda, then an argument is x. Then our expression is x plus 5. And now we are calling our function x. Our function x that you assign it to a variable x, and we are calling it with an argument of 1. So this makes it 1 plus 5 to make it 6. And so in Python, we also have what we call default functions, default arguments. Sorry. So in this example, I have a function greetings that takes name the parameter, and I'm giving it an argument and none as a default when it's not defined. Next, I'm having it just print hello name. Then when I call greetings with a name, it certainly will print a name. Then when I call it without a name, it should not print a name. So that's with an M, and then without. Oh, so we are moving on. In Python, we have strings. Then we have this what we call a cool feature in Python. Feature in Python. This is called f strings. So as you can see here, we are having a string data, then first part, second part of the string, then course name. Now we are concatenating our string. So we are using string f string formatting. So we just use like a placeholder for our variable first part, then the second part variable, then we are printing our name combined. We have exceptions in Python. Example, we will use a try and except. So try n is a variable, then n divided by 0, as you know, that's infinity. Then we can catch that an exception by printing out something, the singularity. You know, you if you ever heard of singularities in black holes. So let's move on. Next, we're having lists. Lists just store multiple items in a single variable. These are not synonymous to arrays in other programming languages. So we can see here, this variable list, and in Python is a dynamic programming language. It means that you don't have to define data type to a variable. So this you just assign a variable to a list, then Python will figure out the list. So we have in a list having three items, and lists just like arrays starts with the index 0 to, in this case, 0 1, and that will be 2. So to print a list, just print using the keyword print that. So we have what we call list comprehension. So list comprehension, as you can see here, we are having a variable and we are creating a list on the fly. Actually, we are not creating a list on the fly. As you can see, we are having for X in list, so we are listing items from our lists, and we are checking if A exists in those items. So this will only return true values having an A in them from this above here. Moving on, we have unpacking of lists. So length gives you a length of a list. That will be 3 in our case. Then we unpack all the elements of lists using this format. Then you can print the list. You can print the variables from that. So as you can see, we have the cherry there. Next, we have what we call tuples. In Python, these are kind of a list, but they cannot change. So to define a tuple, you use a square bracket. You use brackets. Then the list, you use square brackets. So these are lists. These are tuple. Then this is another format to define a tuple. So in this example, my lists element, this will be element. I'm modifying my list element at index 1. That will be the second element to 3. So the list now will be 1 3. Now we cannot modify tuple. We can see there is an error, type error, when trying to modify a tuple. Okay, tuple are convenient ways of returning multiple values from functions, as you can see here. I'm having a function add and multiplication. The function is taking in x and y as a that will be x and y are parameters, but now for those arguments that I'm passing through, these arguments will be added and multiplied accordingly. Tuples can also be used on multiple assignment and swapping. Yeah, so as you can see, these are multiple assignments of a variable x and y, x and y. So in this x is 1. Actually, y is 1, x is 2. So when I print y, I get 1. And when this Python way of swapping, so x for y, y for x, and when I print that, I have 1 and 2. So another fundamental data structure in Python, we have what we call dictionary. And the dictionary, we have key and we have values. Example, to define a dictionary in Python, use curly braces. So in our example, we're having, I think, a country and a capital city. So for UK, you're having London, Russia, you're having Moscow. Okay, so nations, Russia, this will return as a key because we are calling on with the, actually Russia is a key in this case and Moscow is a value. Doing this, I think this should give us Moscow the return value. Then try. We are trying now something that does not exist in our dictionary, US, and we'll catch that exception by key error. US does not exist. So US is not in our dictionary. You can also check the existence of key using keyword in. So is Russia in nations? That should work. That should be true. Okay, let's confirm that that's true. That's true, then US nations, this will be false. Next, we have what we call, we can assign key value pairs using square brackets. So nations, we are adding in Ukraine and we are giving it a value. So Ukraine's a key, then value is a Kiev, capital city. Then you can check dictionary by printing it. Then yeah, also adding in UK. Yeah, UK, but now this kind of modifying UK to Westminster. So this is the first with the Ukraine added. Then this second with the Westminster as an alteration of the UK capital city or whatever. Next, we can get keys by using function keys, values by using a function values, and items by using a function items. An item is a key value pair. As you can see here, you can try to print items from a dictionary. Having it. Then next we are having what we call counter. Counter turns a sequence of values into a default dictionary. So in this case, we are first importing our counter from collections. Then, as you can see, these are lists with values 10 from range 1 to 3, I think 0 to 10. Let's check the values of this list. Can check this by using print list. Print lists. So we're having lists with, let me just print this. Okay, print this. Print lists. Yeah, so these are the list that you're having. Then next we are doing what we call extend. Extend is just adding the lists, extending the lists. So in this case, we'll have 2, 6, 7 added in our list. So let's print that new list using this keyword. So you can see we have this added. So as you can see, we have multiple instances of 4, 6, 7. And so let's convert it to a dictionary. As you can see, we have this dictionary. This is key 2 with 2, key 4 with that 2. So key 6 with 2, then key 7 with 2, key 8 with 2, then key 1, key 3, key 9, key 3, key 0. So yeah, we just converted our list to dictionary. That's what you should get out from that list, from that example. Next, we have what we call set. A set is a useful data structure. It represents a collection of distinct elements. So in our case, this will have unique elements. So as you can see, these are unlike a dictionary that you give key and key value pair. This is a set. So we can just do this, and Python will know that this is a set. So we are having a set from 0 to 4, and we can use add to our sets, and let's add 4. Let's see what will happen. So you're having 4. Let's add 3. Okay, we have so as you can tell, sets actually does not contain multiple items of the same type. No duplicates in sets. This is what you have to know from here. Okay, now moving on, we have a control flow. Control flow, I think these are controls the if, else, the if else controls. So as you can see here, I'm having a variable y. Then I'm assigning this variable to even. I'm checking if it's even or odd. So even if the remainder is 0 divided by 2, then odd. Otherwise, so we can print that, and we have even or odd come through. In this case, 51 is odd, so we'll have odd. While I think everyone knows while basic control flows. So while x is less than 10, we'll continue evaluating this and incrementing x. So then we are having if else we have if else. This just checks. It's an addition to else if else that checks multiple parts of a program that can later be evaluated. Next, you have what we call project-oriented programming. In many high-level programming languages like Python and the rest, the C# and C++, we have object-oriented programming, and this helps us not to rewrite pieces of code over and over. We can reuse it by calling upon it. So in Python we have classes and we have what we call inheritance. But first, let's see how class works. So as you can see, we have a class student, and these first functions, this first function of our class, and is a special function. It's called a constructor function, and this will be evaluated every time we instantiate our class. So this is what is called every time we create an object from our class. This is called an instantiation of our class student. The basic that takes in a name and age, and I'm having a method, and this is another method. In object-oriented programming, and function inside of a class, we call it a method. Then a variable will be an attribute of a class. So as you can see, I'm using the f-strings formatting. Then I will have print name and age. This now, when I call student with the arguments will and term, that's now instantiation. Now we'll have these as objects. Then I can act on that object with a method introduction, and that's the one that will print out